Hello guys, welcome to Voltmeter and Ohmmeter. Now let's start with the voltmeter part. And here in voltmeter you can say it is opposite to that of ammeter. In the words used to describe the ammeter, you can use the opposite words to describe the voltmeter. So it is a device used to measure potential difference or voltage of a circuit, whereas ammeter used to measure current. And here there was a low resistance device shunt in ammeter connected in parallel, but here we have a high resistance device named a multiplier connected in series with a galvanometer, which makes the voltmeter part. And here we can adjust the value of R until we get a full scale diffraction Ig. And here we can find the value of this multiplier using Ohm's law. So here we have the voltage is equals to Ig current into total resistance with G plus R. So that means R equals to V by Ig minus G. G is of course resistance of galvanometer. Now this part, the voltmeter is always connected in parallel to the circuit. So there are again four reasons, which is you can say opposite to that the four reasons of the ammeter. First, it is a high resistance device, so it must be connected in parallel. Second, in parallel, it measures its own voltage, but also in parallel, the voltage remains the same for the two segments, so that means it also measures the voltage of the circuit. And the third one, in series, the voltage is not the same across the series, so that means it measures its own voltage only, but not of the circuit. And if it was connected in series, then the resistance would be too high, so that the potential would be too low, and it will measure very low PD, which is less than what we actually want. So this is for the voltmeter part. And of course, the ideal resistance, for the shunt it was 0, for here it is infinity, so that the range of the voltmeter can increase. Now for the ohmmeter part, here we only need the description part, so I'll do it quickly. So here Rs is a variable resistance in which we can adjust so that we get a full scale deflection Ig. And here the reading full scale deflection needle is actually this needle of the ohmmeter right here. So that means it actually goes from left to right instead of the galvanometer, which could deflect either left or right. And here this point X and Y, let's say it is short circuited, which means basically the resistance is 0. That means we can get max current. So that means here for the full scale deflection part Ig, it deflects fully down to 0. That means we can get minimum resistance, which is 0. And here now let's say that X and Y, the wire is cut off, right? There's no wire linking those 2 points X and Y. Since there will be no current flowing through it because the wire is not completed, that means technically the resistance is infinite and the scale shows max resistance of infinity. And similarly, this is calibrated between infinity and 0, so that we can get ohmmeter, and here any resistance that we apply, this device measures the resistance directly and shows the certain amount of deflection. This is it for voltmeter and ohmmeter. If you learned something new, please like and subscribe. Thank you.